In this video, we will learn about law of large numbers. Also, we will discuss about two another important concepts from statistics. They are mutually exclusive events and independent events. Okay. So, coming to the law of large numbers, as we have discussed in our previous video, that when number of trials increases, the probability between the experimental probability and the statistical probability or mathematical probability becomes the same. So initially, when trials are few, the experimental probability may be different from the theoretical probability. As the trials increases, these two becomes the almost same. For example, when trials are 10, we can see that heads may be 7 and trials may be 3. Okay, this may be even a vice versa. When 50, we can see 28 heads and 22 are the trials. So when the number of trials are increasing, see the experimental probability and this mathematical probability, when we see the ratio becomes less from it becomes less when the trials are increased. When trials increased, for example 0.702, it has become 0.56. Okay, so similarly, when the trials increases, see in the last row where we see the 10,000 trials, after 10,000 trials, almost the probability is 0.501, that is the experimental probability. Okay, so this is how we can see that no large number, this is a law of large numbers. The other interesting concept to understand in statistics is multiplication rule and addition rule. So to understand that, we have to know first of all the what are mutually exclusive events and independent events. And events, we know that events is a set of outcomes of a trial, we call it events. Okay, what are mutually exclusive event? So when it is a coin, we know that, so there are two possibilities or two outcomes or two results will come, and each result has a 50% of chance, we know that. Okay, and each so whatever the results that come in a trial, we call that is a event also. Okay, when we flip a coin, so we get a, if we get a head, so head becomes event. If we get the tail becomes the event. Okay, so coming to the mutually exclusive events, so when head event comes, so tail event doesn't come. So when such events are there, we call such events as a mutually exclusive events. Independent events, so where the occurrence of one event doesn't exclude the occurrence of that doesn't prevent the occurrence of other event. So such events are called independent events. So there may be overlap in between these two. For example, when we see there is chance for coming A and B together also. For example, when we take a coin and dice, so when we flip a coin and when we throw a dice, so where the event in one so where the event of one doesn't influence the event of the other one, so such events are called independent events. So doesn't affect the coming any number on the dice, so such events we call it independent events. So to calculate such things, so we use the multiplication rule, where both can happen. That means coming of a tail and also coming of 2 or 3 on dice. So both will happen. Whereas what are mutually exclusive events and independent events? So mutually exclusive events, when one event comes, the other event doesn't come. So whereas in independent events, there is a chance or a possibility for happening two events together. So that reason we call it overlapping reason. For example, when we take this Venn diagrams, there we see A is one event and B is one event. These two are completely two circles. That means when A comes, B doesn't come, and B comes and A doesn't come. When we see the independent events, there we see that the two circles they have a overlapping region. That means still that A and B can come together. To calculate mutually exclusive events, we use a formula that is called the probability of A union B equal to probability of A plus the probability of B. So when the mutually exclusive events, when the events when one event comes, the other event doesn't come. So when such case we use this one. So probability of A union B equal to probability of A plus probability of B. So when we see after a trial, see the probability of A or B is becomes 1. Why? Because when the probability of A becomes 1 by 2 and probability of B also is possible 1 by 2. So when we do this additional rule, so that becomes 1. So the probability of A or probability of B becomes 1. That means 100%. That means when we perform it trial, so definitely we get either head or tail. So when we get a head completely, that becomes 100. If we even get the tail, so that becomes 100%. Okay. So in case of these independent events, there we use a formula that is called probability of A intersection B equal to probability of A into probability of B. Here we use multiplication rule. So this probability of A intersection B means that overlapping region. That means when we say that independent events, so that means we are talking about the probability of coming both A and B. So to calculate probability of coming A and B is so that depend for that we multiply probability of A event with the probability of B event. So for example, when we calculate a probability of coming head on when we flip a coin, and when we throw dice, probability of coming 6. So that becomes probability of coming A is 1 by 2 into probability of coming B, that is 1 by 6. So that becomes that becomes 1 by 2. That means 50% there is a chance for both coming these two events together. Okay. So in addition to that, we should understand this thing, that means conditional probability, which is also important. So apart from that, no, sometimes we need to even use the union formula. There is the probability of A union B, where we discuss probability of A or probability of B with the formula of probability of A plus probability of B. So sometimes there is we have to subtract the overlapping region, so that calculation. For example, when we take the mutually exclusive events, for example flipping of coin, so there we don't find any overlapping region. So sometimes even to calculate probability of a probability of A or probability of B, it is not always a mutually exclusive events. Even sometimes we find a overlapping region also to find out the probability of A or probability of B. For example, when we want to know how many people they drink tea, or how many people they drink coffee, it is not always like no, it is not always that no, when people drink tea doesn't mean that they don't drink coffee, or people who drinks coffee, it doesn't mean that they don't drink tea. So that's why we need to when we have to calculate such events, so since these are not mutually exclusive events, and drinking coffee doesn't affect the drinking of coffee, and drinking of coffee doesn't affect the drinking of tea. So when we have to find out a probability of drinking a coffee or probability of drinking a tea, so there we have to remove the overlapping region, because there if we directly calculate probability of A plus probability of B, so what happens, no, the probability of A, so the probability of A means they drink coffee, tea, and also some people they drink coffee in the A. So when we take the probability of B, so we add again the people who are in the A. And also when we take the probability of B, so these people they drink coffee, along with that some people they drink tea. So that becomes that means we are adding two times the people who are in the A in the B again, and we are taking the people who are in the B in the A. So that's why to avoid that, so events, to calculate probability of A or B in the events which are not mutually exclusive events and independent events, so there we use the probability of A union B equal to probability of A plus the probability of B minus probability of A intersection B. So this probability of A intersection B means that is overlapping reason. That means these people they're appeared twice in the total data. That's why we remove them and we calculate the their probability. Okay, the other one is the conditional probability. So conditional probability, it is calculated by a formula that is called a probability of for example, if you want to know probability of when one event happens, so if that event affects the other event, so when one event happens and that event affects the other event, so there we use a conditional conditional probability. So in a mutually exclusive also, there one event affects the other event. So how that affects, so completely that excludes the other event. But here it's not like that. When one event happens, though, the probability of the other event is coming of other event is more. For example, when we find a person with a fever, so the probability of having that person same the dengue fever maybe is more. So when we find a person with a fever, so already one condition is there. So already one event is there. The probability of the other event, that is dengue fever, is becomes more. So to find out the probability for such conditional situations, the formula which is used is a probability of A by B. So when we say probability of A by B, when B is true, that means when the person has fever, finding the probability of A, that is a dengue fever. So for that, the formula is probability of A by B equal to probability of A union B. So where probability of A intersection B, so which is a overlapping region. So we divide that the probability of B. So that overlapping region, that means overlapping region means the persons who have the two conditions, we divide that with the only persons with the B condition, means with only fever we divide that with only persons with the fever. So this is the formula for a conditional probability. So usually we see the events like mutually exclusive events, where one event affects the other event, and we use the additional addition rule. Then other one is independent events. When we say independent events, one event doesn't exclude the other event. Okay, one event doesn't exclude the other event. So there we use the multiplication rule, and there we calculate probability of both coming together. When we say mutually exclusive, where we calculate probability of A or probability of B. In the independent events, where we calculate probability of coming both the A and B. So there is another one, so where we use the addition rule only. But we use addition rule when we want to find out the probability of A or probability of B only. But in this condition, one event doesn't affect the other event, doesn't exclude the other event. That means we see the overlap in the two conditions, where in the independent events, where we find out both A B, coming of both A and B. And also using the overlapping region, we can find out probability of A or probability of B. So when we use overlapping region, that is to find out the probability of A and probability of B. So we probability of A and probability of B. For overlapping regions, generally we use for the finding the overlapping regions, generally we to find out the both probability of A and B. But when we use the overlapping region to find out only probability of A or only the probability of B, so we subtract that overlapping region from the whole sets. That means from the two events, so that we will get the probability of A or B, where one event doesn't affect the other event. So the other category is the conditional category. So conditional probability, there one event affects the other event, but one here it's not like additional rule. So in addition rule, where we subtract the overlapping region from the total, so to find out probability of A or probability of B. But here when one event happens, the occurrence or the probability of the second event is affected by the previous condition or the previous event. So in such case we use the conditional probability. For example, as I said, no fever, when a person has already fever, the probability of dengue fever becomes more. So like that, we calculate here also we use the overlap region only, but uh, we perform division on this overlapping region by taking the already happened condition, that is the probability of B. So this is about the probability. Thank you so much.